So today we're going to be working with percent composition or mass percent to calculate and determine what is the percentage of each element in a compound. We will also be working with calculating the mass of each atom or element if you know the percent composition or percent mass of your elements that make up a compound. So, to do this for either problem, you need to make sure that you understand what formula mass, molecular mass, or molar mass is. And remember, this is where you're going to use your periodic table and calculate the total mass of all of your elements that make up your compound. Formula mass is just working with an ionic compound, molecular mass is working with a covalently bonded compound or a molecule. So remember, gram atomic mass, gram formula mass, again, it's going to be the same thing. Gram atomic mass is where you would go to your periodic table, look up the element, and then round. Because atomic mass is the mass on the periodic table. The gram formula mass would be looking up and saying, okay, hydrogen has the mass of 1. Oxygen has the mass of 16. I have 1 oxygen and 2 hydrogen, so my total mass of my compound is going to be 18 grams. So percent composition is the formula we're going to work with first, and this is the formula for percent composition. I will give it to you so you don't have to worry about memorizing it. So with the percent composition, the formula is going to be the mass of your element sample divided by the entire sample mass times 100. So for every molecule of water, it does not matter if you have a glass of water, a bucket of water, or a bathtub or a swimming pool of water. 11% of it is going to be made up of hydrogen, 89% of it will be made up of oxygen. So let's take a look at our first problem. So some of them are going to be very simple, like this one here. We have a compound composed of carbon and oxygen, and the mass is 88 grams. 24 grams are carbon, 64 grams are oxygen. So since I give you all of the numbers in this problem, you're going to use your formula where it is the mass of your element divided by the mass of the sample times 100. So first off, let's look at carbon. We know the mass of carbon is 24. We know the mass of our compound is 88. So 24 divided by 88, enter, times 100, that gives us 27%. You can go on and round these percents to the nearest whole number. What's the percent of oxygen? Well, I give you the mass of oxygen to be 64. The mass of the compound is 88. So 64 divided by 88, enter, times 100, enter, and you get 73% oxygen. Please do not use your percent sign in your calculator. Just use how the formula is wrote. There's a way that you can check your percent comp problems. Your percents, when you add them up, should equal 100. Now, you may every so often get like 99 or 101, and that's because of the fact that we're rounding our masses and we're also rounding our percents to the nearest whole number. If you really want to be exact, you don't have to round these masses, and don't round your percents. Leave a couple decimals and then you'll get closer to 100. But it's okay if you want to go on and round. So my next example that I'm looking at, I'm asking what's the percent composition of carbon and oxygen, and I give you the chemical formula, but I don't give you any of the information. This is where you're going to go to your periodic table. So we're going to first find the mass of carbon and round it to 12. The mass of oxygen is 15.99, so I round that to 16. I'm going to calculate the mass of my compound, which ends up being 44 grams because I have 2 of the oxygen. Now I'm ready to plug in and solve. I use my total mass of my oxygen. So since I have 16 times 2 gives me 32, divided by the mass of the compound, which is 44, times 100, and I get 73. For carbon, I look at my mass is 12. The mass of the compound I said was 44, so 12 divided by 44 times 100, and my answer is 27%. Again, add your percents together. They should equal 100. So from your problem before, did we end up with the same percents? Yes, we did. So again, it doesn't matter this amount of your sample, your percent composition of your elements for carbon dioxide will always be 27% carbon and 73% oxygen. When you're labeling your answers, please make sure that you label a percent sign followed with your element symbol. Okay, if you want to say oxygen or O equals 73% or C equals 27%, that is fine too, but I have to have the element symbol with the percent sign so I know which one is which. If not, I cannot grade it. And I will give it back and ask you to rework it or add it. So in our next example, we're going to take a look and first find our percent composition of sodium and chlorine in the compound sodium chloride. And then we're going to use our percents to work with our next formula where we find the mass of A. Remember, A stands for atom, or you could say element. So let's first look at A. We're working with sodium chloride, and we're going to find its percent comp or mass percent. And since I'm not given masses, I go to my periodic table. Sodium has the mass of 23 grams. Chlorine has a mass of 35. Again, I'm rounding them to the nearest whole number. So when I find my total of all of my elements, the compound's mass is 58 grams. To find your percent of sodium, I take my mass of sodium, which is 23, divided by my mass of my compound, which is 58. So 23 divided by 58 times 100, you get 40% sodium. To find your percent of chlorine, you take 35, which is the mass of chlorine, divided by the mass of your compound, which is 58. So 35 divided by 58 times 100, and that gives you 60% chlorine. Now that you have your percents, you can use your percents in your next formula to find the mass of each element in that sample. So that formula is going to be your percent of your atom or your element divided by 100 times the mass of the sample. So in B, I said, what are the masses of each element in a 40-gram sample of sodium chloride? So that's why I had to work out my percents. A lot of times, especially like with quizzes, your percents you're going to use and piggyback into your next number. So like some of your practice problems are going to do the same thing, or your test. So it's really, really important that you check to make sure, did I calculate my percents correctly? So 40 plus 60, yes, that gives me 100, because you may use them in a future problem, and you want to make sure that you do not miss them. So if I want to find my mass of sodium, I take my 40%, and notice I'm just writing 40 here. I'm not putting 40 and then using a percent. So you simply put in your percent number. Again, not the percent. So I'll do 40 divided by 100 times my mass of my sample, which my sample mass is 40 grams, which I get 16 grams. To find my mass of my chlorine in this sample, I'll take my percent, which is 60. So I just take the number 60 divided by 100 times 40, and I'll get 24 grams. Now, the way that you can check yourself with your mass of is add these two numbers together. Do they equal the sample of your mass, 16 plus 24? Yes, they do. So let's take a look at another example. Again, we're going to be looking at what's the mass of a carbon and oxygen if we have 88 gram sample of CO2. So since it says what is the mass, that means we're going to use the mass of a formula or atom or element. Where did the 73 and the 27 come from? Well, that came from our future problem here, where we calculated our percent of carbon and oxygen. So that's where those numbers came from. So again, like I said, they're going to piggyback off of each other. So check your work so you don't have an error and then carry it over to another problem. So I know my percent of oxygen is 73. So I do 73 divided by 100 times the sample mass. So the mass of my sample is 88. For carbon, to find the mass of carbon, I use my percent, which is 27, divided by 100 times the mass of my sample, which is 88. So I get 24. Again, check your masses. 64 plus 24 should equal 88, which is the sample that was given to you. Our next one, we're going to find if the mass of the sample is not given, what do you do in this case when we're working with your, again, mass of A? Well, if you're not given a sample mass, just simply use your formula mass or your molar mass of your compound. So this time we're working with carbon dioxide. So I'm going to use the same percents like I did from the previous problem. Again, we worked that out to find our percents on this slide right here. So I plug in my percent of oxygen, which is 73, divided by 100 times, oops, sorry, I'm on the wrong slide. So 73 divided by 100 times, this time we're going to use the molar mass. So we have 1 carbon, 2 oxygen, so that ends up being a total of 44 grams. So I'll take 73 divided by 100 times 44, and that gives me 32 grams of oxygen. I found that the percent of carbon was 27, so 27 divided by 100 times the molar mass, which is 44. So I end up getting 12 grams of carbon. Again, with your mass of problems, make sure you label with grams and that you label oxygen and carbon, or you can say O equals C equals. Again, double check your answer to make sure you are correct. So we have 32 plus 44 gives me a total of 44 grams.